This is the statistics module, which is Unit 4, and we're going to do 8.1, which is gathering and organizing data. All right. So a lot of people will ask you, hey, why are you studying statistics? And the answer to that is because every single profession has statistics in them. That kind of makes the world go round. And in fact, the amount you spend on your insurance for your car is because of statistics. So now I'm going to talk about the different types of statistics. There's descriptive, which is when we organize, collect, summarize, and present data. Inferential statistics is making generalizations, predictions, conclusions about a universal set, which is the population, based on the data collected from a subset, which is a sample of the population. So guys, when I talked about our insurance rates, due to past problems, your insurance rates are based off of inferential statistics, because they said, hey, I have an 18-year-old driving a car, they're more likely to get into accidents, so they need to pay more for their insurance. So that's inferential. Now, if I would go around and let's say I was interested in finding out how many healthy dolphins are in the Tampa Bay region, then I would be doing descriptive statistics, because I would have to find out and have someone do a health test on the dolphins that we were trying to figure out if they're healthy or not. And by the way, speaking about the dolphins, every single dolphin in the Gulf would be considered the population. So the population is the entire group. A sample is a smaller portion of that group. This is what usually people use, because a sample is a little bit easier to get to than the whole entire population. And sometimes the whole population is really, really hard to get. And in fact, when they do the census every year, the population is what they want to know, but basically they end up going door to door to try to figure that out. All right, so now let's talk about random sampling. So random sampling is the one that most people want. Random sampling means that each member of the population has an equal probability or chance of being chosen. So let's say I had a class of students and I had a prize, and everybody in the class deserved the prize, but I wanted to be fair. I would put everybody's name on an equal size piece of paper. Maybe I put it in a hat and I draw it out. That would be random sampling, because every single person in the class has an equal chance of being selected. There's different biases when it comes to statistics, and a couple of them would be voluntary response bias, self-interest study, response bias, perceived lack of an anonymity, and loaded questions. So, sometimes, like, for instance, if I was asking how many people like reggae, and maybe I was on the reggae channel of the radio, then that would definitely be a bias, because I'm asking people who are listening to reggae if they like reggae. So that's the kind of biases they're talking about there. All right. Two types of data. Quantitative, which is categorical, are pieces of information that allow us to classify the objects under investigation into various categories. For instance, if I wanted to separate people in terms of their zip code, I could do that. That would be categorical or quantitative data. Another example that's given in the notes is area codes. So, for instance, the area code is assigned to an area. So, for instance, St. Pete is 727. Well, Pinellas is 727. And Tampa is 813. Those numbers don't mean anything. Like, 813 is not better than 727. Okay? But the quantitative data, these are responses that are numerical in nature and with which we can perform meaningful arithmetic calculations. For example, everybody in here gets a test score. So the person who gets an 87 as compared to the neighbor who got a 72 means that that 87 is a higher score. So therefore, it is quantitative data. So we're talking about some kind of system in which the numbers mean things. Okay. All right. So we're going to do this next problem, but I'm going to put this in a part 2. So part 2 of 8.1. Okay, so stop this video and you can watch the next one.